Okay guys, let's go through some review over slope and slope-intercept forms so that I can make sure you have a good understanding for the problems for this week. So when you first of all start talking about slope, there's kind of a couple important ideas about it, that you need to know. The first one is typically they use the letter M when they talk about it. And they use rise over run typically when they have some kind of a graph. And they use y sub 2 minus y sub 1 over x sub 2 minus x sub 1 when there are 2 points. And they want to figure out the slope from 2 points. Sometimes you'll also see something that looks like this. The triangle stands for the Greek delta, which means change. So this wants to know how the y's are changing on the top compares to how the x's are changing in the bottom. So I'm going to go through a couple of those with you so you have a good idea of how to solve those. Also, we have to be able to write things in slope-intercept form. Remember, this M part right here is your slope. And this part right here, that B value, is your y-intercept. And your y-intercept is really the spot where it hits the x-axis. Or excuse me, y-axis. So they want to know exactly where it hits at. And we're going to go through some examples so you can see that too. Okay, so if I start to look at a problem like this, they want us to find the slope, and I have a graph. So that means that I want to use the fraction rise over run. Now, a lot of times the best way to do it is usually to find 2 points that are exactly on the line. And you can see right now on 1, 2, 3, and 4, there are 2 points that are on the line. So typically what I do is to make a triangle between those points, so that I can use that to help me count. Now, 3 and 4 are a little special, and we'll talk about those in a minute. But if I go to set this up, this side is going to be my rise, and that side is going to be my run. So if I look at this rise right here, I want to count how many boxes it actually goes up. So if I look at this, I know 1, 2, 3, it goes up 3. 1, 2, 3, 4, 5. It goes across 5. So if I do my rise over run, it's going to be 3 over 5. Now, the other thing that you kind of need to pay attention to with this is that line looks like it's going uphill, which means that your slope is going to be positive. So anytime it's going uphill, it's going to be positive. If it looks like it's going downhill, I know it's going to be negative. Okay, so on number 2, I'm going to do rise and run again. And I can tell it's going down, so I know my rise has got to be a negative number. So 1, 2, 3, 4, 5, 6 down. So negative 6. 1, 2, 3 for the run. So if I do rise over run, it's going to be negative 6 over 3, which is going to be negative 2. Okay, now, what's different about 3 and 4 has to do with the fact that I can't make a triangle. So if I were doing anything, I can tell on this problem, let me get a darker color here, that I have some kind of a run, but I know on this one my rise is going to be 0 because I have no way to kind of make that triangle that went up like this, like I did on my other ones. Now 1, 2, 3, 4 would be my run. So if I do rise over run, it's going to be 0 over 4, which is 0. Now if you look at that line, it kind of makes sense that it's 0 because my height never changes. It's a flat line. So anytime you have any kind of a flat line, you know that slope's got to be 0. Now with 4, kind of our issue on this one is that I have a rise, But for my run, I don't have anything. I don't have any line that kind of goes over that way. Now on the rise, 1, 2, 3, 4, 5, 6, 7. I have 7. So if I do my rise over run, it's going to be 7 over 0. And if I put that in my calculator, I'm going to get some kind of error. So whenever you get an error, that means your slope is going to be undefined. Now the big thing for this is that undefined slope happens anytime you have a vertical line. Just like when I have a slope of 0, that's when I have a flat line, so I have some kind of horizontal line. So those are kind of the big ideas when you have an actual graph to go from. When you have points, it's a little different. So if I take a look at this, you're going to see me do that change in y over change in x to be able to get this. Now I can tell my y values are this. So here's the way that they go in. I have to see what the change is and how they're changing. So I'm going to subtract. So it's going to be 6 minus a negative 4. And on the bottom I have to do my x's, so I have to go in the same direction. So my x's are going to be negative 2 minus 0. Now you do need to make sure that that's one point and kind of that's the other, or you're going to know that you've made a mistake there, and that's going to be an issue. Okay, now with this one, those two negatives become a positive. So 6 plus 4 is 10. And negative 2 minus 0 is going to be negative 2. So 10 divided by negative 2 is going to be negative 5. And that's going to be my slope. Okay, let's set up the next one. So change in y over change in x. And when I start with y's, it's going to be 1 minus 1, which is 0. And now listen, no matter what the bottom is, it won't matter if there's a 0 on the top, it's going to be a slope of 0. That would mean if I were to graph these, they would both be on a horizontal line, flat line. Okay, on number 6, change in y over change in x. So 2 minus 4. So that's going to be negative 2 on the top. On the bottom, 5 minus negative 1. It's going to be plus, so it's going to be 6. So if I reduce that, it would be negative 1/3. So if I were to graph this, this would be a line that would be going downhill. Okay. Now on 8, change in y over change in x. So 5 minus 2, which is going to be 3. And then negative 4 minus a negative 4. So that becomes plus. So negative 4 plus 4 is going to be 0. Now remember, whenever it's 0 on the bottom, that means it's going to be an undefined slope. Okay, that also means that it has to be some kind of a vertical line if I were to graph that. Okay, so those are the big ideas with slope. So now let's talk about how to write the equation.